students, welcome to VidyaVardhini Academy. In this video, we are discussing valence bond theory in coordination compounds. Okay, so for that I am taking one complex. Name of this complex is hexaamine cobalt 3 ion. Okay, when this complex is given to you, it will be asked to calculate it will be asked to identify hybridization, magnetic behavior and geometry of the complex. For that, first you should understand, in the given complex, the central metal atom is cobalt, right? The electronic configuration, right? The electronic configuration of cobalt. Electronic configuration of cobalt is argon 3d7 4s2. This is the electronic configuration. Now when you calculate here the oxidation state of cobalt, cobalt is in +3 oxidation state because ammonia is 0, hence cobalt is in its +3 oxidation state. Now again I will write the electronic configuration of cobalt 3+. So cobalt 3+ is argon. From this cobalt, I should remove 3 electrons, 2 plus 1. If 3 electrons are removed, I get 3d6 4s0. This is the electronic configuration, right? And we can see the hybridization scheme in this way. First, let us write the ground state. Okay, ground state. This is the representation how the hybridization takes place in the complex. Ground state of the cobalt ion, that is cobalt is having 3d7 4s2. d orbital means it can accommodate 10 electrons. So for that I am writing 3d7 and this is 4s, 3d7 4s, and we get 3p, that is 3d7 4s, and we are having 4p. In this I will add electrons, 7 electrons, 1, 2, 3, 4, 5, 6, 7 electrons and 2 electrons because right now it is in the ground state. Now when it comes to excited state is nothing but right now in the cobalt oxidation state is +3. We need to write this electronic configuration for cobalt 3+. This will become 3d6. There are 6 electrons in the excited state and 0 electrons in 4s, 0 electrons even in 4p. Okay, this is 4p, 4s and 3d6, 4s, 0. Let me draw those electrons here. 1, 2, 3, 4, 5, 6. We have to fill each orbital with single electron, then only we have to pair. This is according to Hund's rule, right? Once we are done with this, we can clearly understand that the ligand which is attached to cobalt is ammonia. As ammonia is a strong ligand, NH3 is a strong ligand, pairing takes place. Strong ligand, pairing takes place. Pairing takes place. After once the electrons are paired, see this electron will be paired here, another electron will be paired here. We get hybridized state. Let me draw here hybridized state. Hybridized state, that is we have paired the electrons. These two are already paired and we are pairing another 2 electrons. The leftover d orbitals are 2 and we have 4s and 4p here. Now as there are 6 ligands, we need 6 orbitals to form hybridization. The hybridization starts from 2 d orbital, these 2 d orbital, 1 s orbital and 3 p orbital, d2sp3 hybridization. The hybridization will be d2sp3 hybridization. Okay, now let us understand few things related to the complex. That is, first, what is the geometry of the complex? As there are 6 ligands, geometry of the complex is octahedral. And we already got to know that hybridization is d2sp3. Hybridization is d2sp3, right? Next, what about its magnetic behavior? Magnetic behavior is depending on the number of unpaired electrons. As here we can clearly see that there are no unpaired electrons, all the electrons are paired. The complex is said to be diamagnetic in nature. The complex is said to be diamagnetic in nature. Okay. And one more thing, we can clearly understand that the complex is undergoing d to sp3 hybridization. The inner d orbital is undergoing hybridization. Hence, this complex is said to be inner orbital complex. Inner orbital complex. Okay. And we can draw this diagram or the geometry of the complex this way. Cobalt is the central atom and it is attached to 6 ligands forming octahedral shape. And everywhere it is attached to ammonia ligand, NH3, that is ammonia ligand. There are 6 ammonia ligands. Okay. And the overall charge is 3 plus. This is how we can analyze geometry, hybridization and magnetic behavior of the complex, that is examine cobalt 3 ion. Right. Now let me take one more ion complex, that is the second complex is COF6 3 minus. In this, we can clearly understand that the given complex is anionic complex and the name of the complex is hexafluorido cobaltate 3 ion. Right? We will follow the same procedure as the previous one. First, let us write the electronic configuration. The electronic configuration of cobalt is argon 3d7 4s2. Now when we calculate the oxidation state of cobalt in this, we get again plus 3 because fluoride is minus 1. X plus 6 into minus 1, that is equal to minus 3. We get X equals to plus 3. That is the oxidation state, how we are going to calculate. Right? Then the second step is writing electronic configuration for cobalt 3 plus. Cobalt 3 plus is argon 3d6 4s0. Now coming to the way how we are going to represent this in hybridized form. First, let us write ground state. In the ground state, as we did in the previous case, we have first 3d, then 4s, later it is 4p. Whenever we call it as a 4th orbital, we even have 4s, 4p and 4d also. These orbitals will be empty orbitals. Okay. Now 3d orbital 4s and this is 4p and this is 4d orbital. In 3d we have 7 electrons in the ground state. I am writing those 7 electrons. 4s we have 2 electrons. The same in the excited state. Here we have 6 electrons and 0 electrons in 4s. Okay. 3d, earlier it was 7 and 2 electrons in 4s. Now coming to this, there are in 3d there are 6 electrons and in 4s there are 0 electrons. Let me draw those electrons here. 1, 2, 3, 4, 5, 6 electrons and 0 electrons. We can see in the given complex, the ligand attached to the complex is fluoride. F minus is a weak ligand. When there is a weak ligand, pairing will not take place. Okay, F minus is a weak ligand, therefore no pairing takes place. When there is no pairing, these 4 electrons remains unpaired. Okay, now I am drawing a hybridized state. This 3d will be as it is, 1, 2, 3, 4, 5 and of course there are 6 electrons, 3, 4, 5, 6 electrons in 3d, and the hybridization right now it should start from 4s. As there are 6 ligands As there are 6 ligands, we need 6 orbitals. The hybridization start from s orbital, includes 4 p orbital. There are 3 4p orbital and 2 4d orbital. This is d orbital, 4d. So the hybridization is sp3d2 hybridization. Okay, this is the hybridization of the given complex. It starts from s orbital, includes 3 p orbital and 2 d orbital. Hence the hybridization is sp3d2 hybridization. Now let us analyze what are the remaining points we can understand from this hybridization. First is geometry. Geometry of the complex is octahedral, right? And next is hybridization. What is the hybridization of the complex? Just now we understood that is sp3d2 hybridization. And here there are unpaired electrons. Magnetic nature or magnetic behavior. As we know, when the unpaired electrons are present, it is called a paramagnetic. As the outer d orbital is involved in hybridization, it is referred as outer orbital complex. Okay, and the geometry of the complex can be represented like this. Cobalt is the central atom. It is attached to 6 ligands forming octahedral shape. Fluorine, and it is forming octahedral shape like this. And the overall charge is 3 minus. This is how we understand the geometry, hybridization, magnetic behavior and the shape of the given complex. Now the complexes, in the one complex the hybridization is D2sp3 and in the another complex it is sp3d2. It majorly depends on whether the ligand is a strong ligand or a weak ligand. In order to understand which is a strong ligand, which is a weak ligand, we need to study about a spectrochemical series that is there in our upcoming videos. Please do watch out. Hope you understood these two complexes. We will be discussing another two complexes in the upcoming videos. To learn and to understand coordination compounds in detail, please do follow our YouTube channel VidyaVardhini Academy. Thank you so much.